Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 13.4, Problem 16. This is Section 13.4, it's problem number 16. It says, draw the graph of f of x equals x cubed minus 27x plus 17, and be sure to label the x and y coordinates of any critical points. So we're going to start this multi-step process. Step 1, find the derivative of f of x. So we're going to do f prime of x equals, so the x cubed has a 3x squared as its derivative. And again, that's coming from the exponent of 3 coming down in front times the number in front, which isn't written, but it's assumed to be 1. So my 3 times 1 gives me a 3 in front, and the exponent drops by 1 from a third power down to a second power. So this is the derivative of the first piece of my function. The next piece, minus 27x, will give me a minus 27. Right, again, when you have something with just an x to the first power, its derivative is whatever the number in front is, including the sign. Pay attention to the sign, minus 27. The 17 on the end has no x with it, so its derivative is 0. So my f prime of x is simply 3x squared minus 27. So the next step in the process is take the answer you just got and set it equal to 0. So I will have 3x squared minus 27 equals 0. And now solve it for x. So I can see both pieces have a multiple of 3 in it. So let me put a 3, some parentheses. Inside my parentheses, I'll have x squared and then minus 9. It's still equal to 0. And again, you can check it. Would it factor this way? Sure. 3 times x squared gives me a 3x squared, and 3 times minus 9 is minus 27. And now what's left in the parentheses is what's called the difference of squares. It's fairly easy to factor. You have an x squared, you have a minus, and you have something with a nice whole number square root. So I can leave the 3 in front, set up 2 sets of parentheses, still equals 0. Going to go x plus 3 minus 3. Your difference of squares factors up very easily. And you can verify it, FOIL it out, and you're going to have a 3x and a negative 3x, which cancel off for the piece in the middle. You have x squared and 3 times negative 3 minus 9. It factors very nicely. 2 factors means 2 answers. The x plus 3 gives me an answer of x equals negative 3. And again, if x is negative 3, it will make the equation true. You'll get 0 equals 0. And the other factor of x minus 3 gives me a solution of x equals positive 3. Again, if I put in positive 3 wherever I have an x, the equation becomes true. 0 equals 0. So those are my 2 answers for x, which means I have a critical point with an x coordinate of minus 3. And I have a second critical point with an x coordinate of positive 3. So what I have to do next is find the y coordinate that goes with each of those x's. We can start with the negative 3. To find the y coordinate, put negative 3 in for x in my f of x. Again, not f prime, put in an f of x. So f of negative 3 equals the x cubed will be negative 3 cubed minus 27 times x becomes minus 27 times minus 3 and plus 17. Do the math. Negative 3 cubed, so negative 3 times negative 3 times negative 3 again, and if you multiply that out, it multiplies to negative 27. The next piece, negative 27 times negative 3 is positive 81. Again, pay attention to the signs. The negative times the negative cancels, becomes positive. And there's a plus 17 on the end. Now, if you combine your negatives, positives, the 2 negatives have negative, 2 positives have positive 81, positive 17. So it's going to be positive 98. Positive 98 and negative 27 is positive 71. So one of my critical points has an x coordinate of negative 3 and a y coordinate of 71. So let's go ahead and put that on our graph. Because I tried the problem before I came to the whiteboard, I could see that I'm going to have to deal with a number of 71. I didn't want to run the number scale 1 at a time all the way up to 71. Even 5 at a time, it's starting to make a lot of lines. So I went for 10 at a time. It's a good graph. Negative 3 I don't have exactly on my number scale, but you can estimate by eye. It's about a third of the way up between the 0 and the negative 10. So negative 3 probably about there. Positive 71 I also don't have exactly on my number scale. I have positive 70. So 71 tiny bit higher. So if I put a dot about here, that looks like it's about over 3 up 71 based on the number scale I have. Positive 3 for the x, oops, negative 3 for the x, I should say. Positive 71 for the y. Gives me a critical point. Now that's one of them. There's a second critical point with an x coordinate of 3. So let's find the y coordinate that goes with that. Again, to do that, take my x of 3, put it into f of x, do the math, see what I get as an answer. That's going to give me my y coordinate. So f of 3 equals the x cubed gives me a 3 cubed. The minus 27x will be minus 27 times 3 plus 17. So again, 3 cubed is 3 times 3 times 3 again, times itself 3 times. So 3, 9, 27 is what you get when you multiply that out, 3 to the third. Now, minus 27 times positive 3 is negative 81. And I have a positive 17. So again, my positives, positive 27, positive 17 is going to be positive 44. And my negative, I have negative 81. So positive 44 minus 81, if I'm doing my math right, that comes out to negative 37. Let's see, that should be right. So now, if I do positive 3, I'm down 37. So again, I don't have positive 3 on my number scale, so by eye, about a third of the way between the 0 and the 10. 37 I also don't have exactly on my number scale. By eye, about 3/4 of the way between the negative 30 and the negative 40. So I'm going to put a dot right about there. So that's going to be positive 3 for the x and negative 37 for the y. Now, I know they connect between the two, and it's going to cross my y-axis at 17. I can see as x is 0, that is 17. So I have a flat spot. It's going to come down, cross at about 17, keep coming down, and flatten out. So it flattens out at those two spots. Most likely after it flattens out, there's a change into the opposite direction. But as you can see from some of the previous problems, sometimes it flattens out briefly and continues in the same direction at your critical points. So what I'd like to do, I know the height when x is negative 3. Let's find the height when x is negative 4. Is it going to be a little above or a little below my critical point? So do the math and see what we get. So I can fit it in here. So f of negative 4 equals, the x cubed is negative 4 cubed. Minus 27 times x is minus 27 times negative 4. And then plus 17. So negative 4 cubed is negative 4 times negative 4 is positive 16 times negative 4 again is negative 64. So minus 4 to the third power is negative 64. Minus 27 times minus 4, the minus times the minus cancels, and I get positive 108. And then positive 17 on the end. So now if I put my positives together, positive 108, positive 17, I'm going to have positive 125. And then I'm going to subtract 64, because the 64 is negative. That's going to give me positive 61. So if I go back 4, right, my x is negative 4, my height is positive 61. So on my number scale, a little higher than this. So the answer is, after I go past my critical point, there is a change in direction that comes back down. So at the other critical point, what happens? It's going to flatten out. I'm going to have a flat spot at over 3 down 37. As I go a little to the right of that, does it keep going down or does it turn around and come back up? So I know the height when x is 3. Let's go out to x is 4 and see if the height I get is a little above or a little below my critical point. So let's put in a positive 4 for x into f of x and see what type of height I get. F of positive 4 equals x cubed will be 4 cubed. Minus 27 times x is minus 27 times 4, and plus 17. So 4 cubed, 4 times 4 is 16, times a third 4 is 64. So 4 to the third is positive 64. Negative 27 times positive 4 is minus 108, and plus 17. So my positives, I have positive 64, positive 17. That's going to be positive 81. And I have negative 108. So that's going to be negative 37. Is that, no, 27. So if I go over 4 for x, and I would go down 27, which again isn't exactly on my number line, but I can see it's a little higher than my height of negative 37, so it would flatten out and turn around, change in direction. So the final graph is that kind of tall, elongated zigzag.